Hello students, today I am going to cover up lecture number 8 of unit number 4, which is your transport layer. In today's content, we will discuss about the congestion control, why congestion occurs, what are the solutions for congestion controls, etc. So firstly begin with some basic topics such as data traffic. Data traffic, basically the data traveling on the network is known as the data traffic. There may be a number of sources and there may be a number of destinations or receivers. So between these senders and receivers, the data is traveling from one part to another part. So that is known as the data traffic. The main focus of the congestion control and the quality of service is the data traffic. If the data traffic will be higher, then quality of service will automatically decreases. Similarly, if the data traffic is larger than the capacity of the network, then there will be a congestion. Once the congestion occurs, then there is a need of the controlling mechanism to avoid or overcome from the congestion. In congestion control, we try to avoid the traffic congestion. If that means congestion should not occur. In quality of service, we will try to create an appropriate environment for the traffic to overcome from the congestion. So before talking about the congestion control or the quality control, we should discuss what type of the data traffic. Here you can see along with time, the data rate is not constant. It is varying. This is the burst size, that is the maximum rate of the data. For example, in India, during the daytime, data traffic will be higher because most of the organizations are working from 9 to 5 or 9 to 6. So during this period of time, the data traffic will be largest. So, and it may be possible at 2 o'clock or at 1 o'clock at night, it may be the least one. So, data traffic is categorized into three parts. First one is the constant bit rate. A constant bit rate or the fixed rate. The data traffic model has the data rate that does not change. That means the data traffic will be always constant. This is an ideal condition. This never occurs. In this type of flow, the average data rate and the peak data rate are the same. This type of traffic is very easy for the network to handle since it is predictable. That means the network knows how much data will arrive. So the constant data rate is where can be handled by the network very easily. The network knows in advance how much bandwidth is allocated for this type of flow. Suppose that data rate is the 2 Mbps, so we can allocate maximum 2 or 2.5. That is sufficient, but it will be difficult for variable data rate. So data traffic, variable bit rate. In case of variable bit rate category, the rate of the data flow changes with time. In this type of flow, the average data rate and the peak data rate are different. Average and peak are different. This type of the traffic is more difficult to handle than the constant bit rate because network does not know how much data will be there at any particular of time. Here, a point must be noted: in variable data rate, the data is continuously flowing. There is no gap in the data transmission. Data is continuously flowing over the network. Now we are coming on the third and or last one, data traffic, that is known as the bursty data rate. In the bursty data category, the data rate changes suddenly in a very short time. It may also remains at a const at this value for a while. For example, for 2 seconds, the data rate was the 20 Mbps. Then after, it is ideal. There is no data is flowing. That means data rate is zero for 10 seconds, and for again 1 second it is of 5 Mbps. So it depends. What is the data rate? It is not continuous. Suddenly there is a data with higher speed, suddenly there will be no data, and suddenly there will be a little bit amount of the data is flowing over the network. This is the more difficult type of the data traffic for the network to handle, because profile is very unpredictable, because does not know, network does not know when data will arrive, when data will not arrive, and how much data will arrive. To handle this type of the traffic, the network normally needs to reshape it using reshaping techniques. So the best example of this, couple of years ago, we have seen there was a lucky draw or the DDA flats. So there a large number of bombardment of the data packets from the user side on that particular site. So that site get crashed. So the server was unable to handle that excess amount of the data. So most of the times, sometimes we can see this type of situation in Amazon or Flipkart, when there is a sale of some mobile phone or TV at a particular time slot. Then there is a large number of the data packets are bombarded over that particular website, so that it may get crashed. Now, congestion management. This is one of the important topic, and it is asked in most of the university examination question papers. So make sure, if there is any difficulty, you can ask to me. Congestion. An important issue of the packet switch network is the congestion. Congestion in a network may occur if the load of the network or number of packets sent to the network is greater than its capacity. Then, or we can say the number of packet network can handle. For example, if in real life situation, if a person has workload carrying capacities, we are not measuring it. Suppose that it has some workload carrying capacity, and there will be excesses of work I am putting on him. In that case, it will not respond as it should. So similarly, if the network is having more workload than it can handle, so there will be a congestion. Congestion control refers to the mechanism or the technique to control the congestion and keep the load below the network capacity. For example, you can consider this is a router, and router have the processing capacity of the 15 Mbps, and the data is coming 10 Mbps from this connection and 10 Mbps from this connection. That means 20 Mbps. Now the processing capacity, basically handling capacity of the router is only the 10 Mbps. So definitely it will feel the congestion, and it will start discarding of the data packets. So there are various techniques to overcome from these. In continuation, firstly we will look some some I will put the some more focus on the congestion. The congestion in the network or the internet occurs because the router or switch have the queues of the buffer that holds the packet before and after processing. For example, a router has two input and one output port. So, sorry, here are the three ports. Router has three ports, and each port has the one input queue and one output queue. The packet coming from the particular network or particular host, it is put it into the input queue, and after processing, the route will be decided and it will put it in the output queue. So the packet is coming from input to this one, and after searching the best path in the routing table, it will put into the uh, packet into the output queue. Similarly, for the second connection or and the third connection. So these are the buffers. If this buffer is get full, input buffer get full, so automatically the router or the buffer will start discarding of the data packet because it cannot accommodate, its buffer is full, so it will start discarding of those data packet. When the packet will get discarded by the router, it cannot reach to the destination. When it will not reach to the destination, so destination will not acknowledge back to the sender, and sender's time will get out the timer. In that case, the sender will resend the same data packet again. If the buffer is still full, then that packet will again discarded. So this will cause the congestion on the network. A router, for example, has a has an input queue and output queue for each interface. When a packet arrives at incoming interface, it undergoes three steps before departing. The packet is put at the end of the input queue while waiting to be checked. The processing module of the router removes the packet from the input queue once it is reached at the front of the queue and uses its routing table and the destination address to find the best route. The packet is put in the appropriate output queue and waits to its turn to send. One more point that is not considered or not given in the book, the router also checks the error, whether there is an error or not. If there is any error, it should discard the packet immediately, because if a corrupted packet will reach to the destination by consuming the bandwidth, and then after the network receiver will inform back to sender that there is an error, so there is a wastage of the time and the bandwidth. So to overcome from that situations, the router must discard the data packet if it has encountered an error during the analysis. Now, relationship between delay and load. When a when the load is much less than the capacity of the network, the delay is minimum. Means there will be no delay. If network, for example, consider this is a road and there is only one vehicle is going on this road, so it is much less than the capacity. So there will be no delay. But if number of vehicles are more than the network capacity it can handle or road can handle, in that case there will be a congestion or there will be a delay. The minimum delay is composed of the propagation delay and processing delay, both of which are negligible. Basically, processing delay means router will search for the best path, then after it will redirect to that particular path. So that is known as the processing, and propagation means transmit during the data packet transmitted from source to destination, that is known as the propagation delay. Relationship between throughput and load. Throughput in a network as a number of packet processing through the network in unit of time. That means the amount of work done in unit time is known as the throughput. When the load is below than the capacity of the network, the throughput increases proportional to the load. When the load exceeds the capacity, the queue becomes full and the router have to discard some packets. Discarding of the packet does not reduce the number of packets in the network, because as the sender time will get out, it will retransmit the same data packet once again. So this is the one of the issue. Now in continuation, we will discuss the various mechanism for congestion control. Congestion control refers to the technique and mechanism that can either prevent the congestion before it happens or remove the congestion after it happens. So there are two mechanisms. First one does not allow to happen the congestion. Second one, if the congestion has been occurred, then how to overcome from that congestion. So there are two mechanisms. First one is the open loop congestion control, that is known as the congestion prevention. That means it will not allow to happening the congestion. And second one is the closed loop congestion control. That means it allow to overcome from the congestion if it happens. So there are number of techniques in the both open loop and closed loop. We will discuss each one by one. So open loop has retransmission policy, window policy, acknowledgement policy, discarding policy, and admission policy. While closed loop have 4 points or four techniques: back pressure, choke packet, implicit signaling, and explicit signaling. Explicit signaling is further divided into two parts: forward and backward signaling, that we will discuss little bit later. So firstly, I will cover up open loop congestion control. In open loop congestion control, the policies are applied to prevent the congestion before it happens. Means we will not allow the congestion. Before that, we will stop it. In these mechanisms, the congestion control is handled by the either by the source or the destination. So let us discuss each policy one by one. First one is the retransmission policy. Retransmission is sometimes unavoidable when the packet get lost or negative acknowledgement is there. There will be a retransmission of that particular packet. So retransmission sometimes may get unavoidable. If the sender feels the sent packet is lost or corrupted, the packet needs to be retransmitted. The retransmission in general may increases the congestion on the network, because the same packet is going again and again on the network. So definitely it will increase the congestion. However, a good retransmission policy can prevent the congestion. If the packet is not reached to the destination, then it must be sent to the destination once again. So we cannot avoid the retransmission, but we should design a good retransmission policy that can prevent the congestion. The retransmission policy and the retransmission timer must be designed to optimize efficiency and at the same time prevent the congestion. So retransmission policy must be designed in such type. For example, if between source to destination, this is the source, and this is the destination. If suppose that the round trip time is minimum round trip time is the 2 millisecond, 1 millisecond to send the packet and 1 millisecond to receive the acknowledgement. Then we can we can increase the transfer RTT time. That means total timer total timer we can increase by 2.5 milliseconds. For example, if timer will get out in 2 milliseconds, we can increase its time by 2.5 milliseconds, so that if there is any congestion on the network, so acknowledgement may get delayed. But we cannot make, yes, let it be the 10 millisecond. Round trip time will be 10 milliseconds, means 5 millisecond to go and 5 millisecond to come back. It should be minimum. We cannot increase too much. So this was all about the retransmission policy. The next one is the windowing policy. As we have discussed at the data link layer and transport layer, there are window at the sender and the receiver end. So at the at data link layer, the constant size of the windows are there. Sender and receiver both have the same size. But in the TCP, we have seen the window size are different. That depends on the two factor, that is your congestion window and the receiver buffer. Whatever the minimum in these two, that will be the size of the window. The type of the window at the sender may also affect congestion. So how to design the congestion window policy? The selective repeat is much better than go back NRQ for congestion control. In go back NRQ, if there are 10 packets are sent by the sender continuously one by one, this is the sender and this is the receiver, and it has sent 5 packets. Let us assume 1, 2, 3, 4 and 5, and it get the negative acknowledgement of packet number 2. So in go back NRQ, the packet number 2, 3, 4 and 5, it will resend. That means 2, 3, 4 and 5. It will resend. Although 3, 4, 5 has been already reached to the destination, but in go back NRQ, it will resend the all data packets once again. So, but obvious, there will be a congestion on the network. When a packet is reached to the destination successfully, or maybe reached to the packet at the destination successfully, what is the need of the retransmission that data packets again? So we should not opt for the select go back and RQ. We will select selective repeat. Whatever the packet has been lost or the acknowledgement, the negative acknowledgement we have gotten, we have to send only that data packet, not the entire data packets that we have already transmitted to. We are sending once again. What is the benefit? So the retransmission policy must be such that there will be a minimum amount of the retransmission of the packets. So in go back NRQ, when a timer for a packet's timeout, the several packets may be resent, although the same may arrive safe and sound at the receiver. The duplication may make the congestion worse. The selective repeat window, on the other hand, try to send the specific packet that has been lost or corrupted. So better policy is the selective repeat rather than the go back and RQ. Next one is the acknowledgement policy. As we know that the receiver and sender both has the buffer. So there are two policies. Uh, First one is the stop and wait, and second one is the sliding window. In a stop and wait policy, the sender will send a packet and wait for the acknowledgement from the receiver. Then after, sender will send the second packet and it will wait for the acknowledgement. So corresponding to each packet sent by the sender, it requires an acknowledgement from the receiver. So, but obvious, corresponding to each packet, if there is will be a acknowledgement, it will increase the congestion on the network. It will also consume the bandwidth and slow down the network capacity. The acknowledgement policy is imposed by the receiver or may affect the congestion. If the receiver does not acknowledge every packet it receives, if the packet does not acknowledge every packet it receives, it may slow down the sender and helps the prevention congestion. For example, if I have the window of the 10 packets, so I will send the 10 packets continuously. If I will get a response from the sender side of 8th packet, that means acknowledgement from the 8th packet, that means 7 packets have been successfully reached to the destination. So all, I am not sending the acknowledgement for the each individual packets. The receiver will send a single acknowledgement that has a particular number, acknowledgement number. If it is 8, that means before that each packet transmitted by the sender is received by the receiver successfully. So it will automatically prevent the congestion. A receiver may send an acknowledgement if any of the packet is to be sent a special timer expires. A receiver may not decide to acknowledge only n packets at a time, means one by one it will not send. Second, one more point, if sender and receiver both are communicating, means full, there is a full duplex communication, so it is better to send an acknowledgement as a piggybacking, so that the receiver has no need to send an individual packets that will consume the bandwidth. So piggybacking is an important concept that may be incorporated in the acknowledgement policy. Last one is the discarding policy. A good discarding policy by the router may prevent the congestion, as I have discussed, because if an error packet contains an error, it should not send to the destination. It should be discarded by the router which experiences that there is an error, because each routers uh, decapsulate the packet for the source address and destination address, as well as for the checking the error. That may be checksum or CRC, there will be some mechanism. So at the same time, it may not harm the integrity of the transmission. For example, if a router receives a packet containing an error, it should destroy the packet at its end and should not allow to packet the forward the packet to the network. Otherwise, it will consume the bandwidth and receiver will discard it. So the good congestion policy or discarding policy may improve the congestion control. Admission policy. Admission policy, the which is the quality of service mechanism, can also prevent the congestion in a virtual circuit network. Switched in a flow, first check the resource requirement of the flow before admitting on the network. If I am feeling there is a road that have the congestion, will I follow that road? No, I will wait. The congestion should be reduced, or I will follow the another path. So switches in a flow first check the resource requirement of the flow, means the data packet is transmitted by the particular sender. Firstly check how much bandwidth is it required before admitting to the network. If it is lower than the capacity of the network or that switch or that router, it will get admitted immediately. If it is more than the capacity of the network it can handle, the network means router and switches, so it should not get admitted on the network. The router can deny to establish a virtual connection if there is a congestion on the network or if there is a possibility of the future congestion. So these are the open loop congestion control mechanism. Now we will discuss about the closed loop congestion control. Closed loop congestion control mechanism allowed to elevate the congestion after it happens, means removal of the congestion that has been already occurred. There are several mechanisms have been used by the different protocol or different techniques. We will discuss one by one. First one is the back pressure. The technique of the back pressure refer to the congestion control mechanism in which the congested node stop receiving the data from the immediate upstream nodes or nodes. This may causes the upstream nodes or the nodes to become congested and then in turn reject the data from their upstream nodes or the nodes and so on. Backpasser is the node-to-node congestion control that starts with a node and propagates in the opposite direction of the data flow to the source. Means, suppose that this is the router that felt there is a congestion. It will inform back to the upper layer router. It will inform back to the upper layer and it will inform to the upper layer. So this may be possible if there are a number of networks are admitting, means there is a one path is this one, another path is this one, third path is this one, fourth is this one. There are total 5 paths. So this may experience the congestion. So it will inform to the upper layer. So kindly slow down your speed. It will inform to the upper layer. So this technique is known as the back pressure. So it can be applied only in the virtual circuit because it knows which is the path the packet is following. So in virtual switching technique, the back pressure is one of the most suitable techniques to overcome from the congestion. Next one is the choke packet. Choke packet. In the choke packet, the congested node directly informed to the sender. In the previous one, it will inform to the its previous one, then it will inform to the its previous one, then after it will inform to the sender. While in case of choke packet, a special packet is sent by the router that is feeling congestion to a particular sender a packet. That packet is known as the choke packet. The choke packet contains the information to slow down the transmission speed. Here, look up the bookish definition. A choke packet is a packet sent to a node to the source to inform of congestion. In the choke packet method, the warning is the form of warning from a router which is encounter the congestion to the source station directly. The intermediate nodes through which the packet has traveled are not warned. It will not give the warning to the previous one or its previous one. So it will immediately directly inform to the sender by sending a packet. The example of this type of control is ICMP, Internet Control Message Protocol, When a router in the on the internet is overwhelming with IP datagrams, it may discard some of the packets, but it informs the source host using source quench ICMP message that I am feeling the congestion. Kindly slow down your data transfer speed. Next one is the implicit signaling. Implicit signaling, for example, this is a real life example. If I am asking a question to you and you are not giving the answer. This is an ideal example. So I will ask one question, second question, third question, fourth question. Then after this may be possible, I will think he is not in the state to give the answer. So I will ask the question to the some another person. So this concept is bring into my mind implicitly that there is some problem or at present state of the student he is not able to give the answer, so I should not demoralize him. In implicit signaling there is no communication between the congested node or the source node. Means if there is a node that is feeling the congestion, it will not inform back to the sender. The sender will automatically guess there is a congestion because it will not get the packet, acknowledgement packet. It has to retransmit the packet again and again. A number of retransmission shows that there is a congestion. So this will automatically detect by the sender. The source guesses there is a congestion somewhere in the network from other symptoms. For example, when a source sends a several packets and there is no acknowledgement for a while, one assumption is that the network is congested. The delay in the receiving an acknowledgement is interpreted as congestion in the network and source will slow down its speed. The last one is the explicit signaling. In the explicit signaling, the node that experiences the congestion can explicitly send a signal to the source or the destination. This is also done in the choke packet? No, it is different from the choke packet. The explicitly signaling, however, different from choke packet method. In choke packet method, the separate packet is used for this purpose. In the explicit signaling method, the signaling is included in the packet that carry data. There will be a no separate packet. The packet during the transmission from source to destination or destination to source, an extra bit is attached by the router or enabled by the router. Yes, I am feeling congestion. If implicit signaling occurs in the frame relay congestion control only, can occur either in the forward or backward direction. So in forward signaling, a bit can be set in the packet moving in the direction opposite to the congestion. So if the direction is this one, so in the backward signaling it will be sent it to the source. This bit can be warn the source there is a congestion that it needs to slow down to avoid discarding of packets. Similarly, in the forwarding signaling, in the flow of the data, the information or the bit is set in the packet to inform the receiver. A bit is set in the packet moving in the direction of the congestion. This bit can warn the destination that there is a congestion. The receiver in this case can use the policy such as slow down the acknowledgement and elevate the congestion or lessen the congestion. So This was all about the TCP congestion control mechanism. If you have any query, you can contact to me on my mail ID. Thank you.